These are the solutions to Chapter 7.2 textbook homework problems. The first problem we had to complete was 6, and I only asked for 6A and C because they're very repetitive, so we'll just do A and C. First question, determine the area of the standard normal curve that lies to the left of these values. And again, we want to reference our notes. You have your notes out. You've been doing it, and in our notes we talked about the standard normal curve, the distribution, what it looked like, and again this is with reference to z values, and we were looking for area. So you have examples to look at. So we're going to draw the normal curve, and then we'll go ahead and use stat crunch to calculate the area. And so for A, what we're really trying to solve on A is this, right? That x is, we want to the left, probably x is less than negative 3.49. And again, stat crunch uses x here. The variable is z. We're talking about z-scores versus some x value, which we'll look at later on. And so to calculate that, I'll draw it real quick. To calculate that, you draw your normal curve. I'm going to do this really quick. We know for a standard normal, the mean is 0, standard deviation is 1. So in this case, negative 3.49 is somewhere over here. And so we're looking for this area right in this spot. What's this area equal to? That's the answer we're going to get. And so again, we go to stat crunch, stat calculators, normal, and we're looking for the area to the left. It's already 0 and 1 because this is negative 3.49, compute, and so you get 0.00024, and so that would be the answer for this one here, 0.00024. And so now looking at problem B, looking for the area to the left. Area to the left under the standard normal curve of z equals negative 0.92. And so for C, we're looking for this. 0.92 is going to be somewhere over here. And so it's the area over here we're talking about. So again, we just go to stat crunch and then put in 0.92 is to the left. So we're going to use the less than symbol there. Compute, and you have 0.821. And so that would be our answer there, 0.821. Okay, so let's continue on with 8AC and 12AC. We'll do those together real quick. And so they're the same. We're talking about the same type of problem, finding the area underneath the curve. Finding the area underneath the curve of to the right. And so we have these values here. We're looking at A and C. And so for this, for A, we're going to have to calculate this. And so this to the right is greater than negative 3.49. And so we're going to look for that value. And for C, it's going to be greater than 2.23. I would draw out, you guys should draw this out. Again, for our time per, well, let's just do it. You're going to draw that out, and this is for A. And then your z value right here, z equals negative 3.9 is going to be somewhere over here. Z equals negative 3.49. And then the area to the right is going to be all of this over here. And then for C, we would do the same thing. You're going to have a normal curve. Remember, the mean is 0 in the middle. What's the z value? 2.23. It's going to be somewhere over here. And so then we use stat crunch to get those answers again. Go to stat crunch, and we want it to the right. Negative 3.49. Compute. Stack Crunch uses a greater than or equal symbol. It doesn't make a difference for us in this case. So it's 99975. Pretty much 1 if we wanted to round that off for the first one. 99976.99976 would work there. And then x is greater than, so we're looking at this over here. That's 2.23, and so your answer here is going to change this to 2.2 greater than compute, and it's 0.013, 0.013 in this case, to 3 decimals, 0.013. I usually go to 3. This could be 1 if you were going to approximate that to 3 decimals. So that's the answer for A and C. B and D, you would do the same, but I didn't assign those. 12, A and C. Determine the total area under the curve to the left of negative 2.9 or to the right of 2.49. So for A, we're looking at this here. The probability that x is less than 2.94 or x is greater than 2.94. So in this case, what we're looking at is, there's your normal curve. We're looking for a value here. Z equals negative 2.94. There's another one here, Z equals 2.94. So what we're really looking for are these areas right here. We need to get those areas. And so again, we're going to use Stack Crunch to do that. Go to Stack Crunch. 2.94. So we have 0.002 on one end. And if you put the negative, oh, we want it the other way, 0.002 also. So you can see those little values right there. They're equivalent, symmetric, so we are going to get the same answer. So in this case, I get for these areas 0.002, 0.002. Again, I rounded to 3 decimals looking at the answer. 0.002 comes from right here, right? And so then now we have our answers here. So this area to those is going to be 0.004. And then for B, we want the probability x is less than negative 1.68 or x is to the right, so greater than 3.05. And so we're going to have to do those two calculations separately. Negative 1.68 compute, and then so you get 0.046 for one of them. So for this one I get 0.046, and then for x greater than 3.05, 0.05 compute, 0.9988, so 0.999. Oh, wrong way. It needs to be greater than, so let's do that again. So no, it's 0.001. 0.001 for this one here. Got to make sure your signs are correct. And so the probability would be 0.047. I would add those two together. So that's problem number 12. Let me fix that 0. There it is, 0.047. Let's go ahead. Problem number 15 now. Number 15, find the z-score that the area of the standard normal curve to its right is 0.25. So again, here we're looking for a value this time, where we're looking for this value right here. What is this x or z-score equal to? Remember, Stack Crunch uses x because it's a generic variable, but here we're talking about z-scores because the mean is 0 and the standard deviation is 1. And so what we're looking for here is we're looking for this x value where this area is 0.25. So we're looking, try to find that x value. We know how to do that from our Stack Crunch here. We know how to do that here. We go ahead and clean this out, and we in here, oops, that's a 1. Here you're going to put 0.25, compute there, and then you can see here's the area as represented, and so the x value you can see has an x score of 0.674. And notice here again, this is a z-score, an x-score there, 0.674. It's not an area. And so in this case, this x value is 0.674. So that's what we have. Now moving on to problem number 19 and 20. 19 and 20 ask you similar things. They just do it in different notation. This exact question here on 15 is the exact same question here. The only difference is they put it in a notation z sub 0.01, z sub 0.02. And so what we're looking for is the z value, where the area in the curve for one of them. We're looking for this value here. This is the z 0.01, meaning that the area in this little spot right here is 0.01. So what's this z value? And then on this one here, it's the same question. Normal curve. You have this here. This is z 0.02. And so what's really asking you is, what's this z value that has an area underneath the curve of 0.02? And so to get those values, and that's what that notation means. So this notation, it means exactly this question. Find the z-score such that the area under the standard norm curve to the right is 0.01. This little notation is this exact same question. Just instead of saying it as a sentence, we write it in notation. It means the same thing. So you just go to here, change this, clear that out because we're looking for that. Put 0.01 in there, compute, and you get 2.33. And so that's the answer for this one here is 2.33. And then to get this one here, we're going to do the same thing. The only difference is you put 0.02 here, compute, and you get 2.05. And so then that's the answer for this one here, 2.05. So again, problem 15, 19, and 20 are exactly the same calculations. One just wrote it as a sentence. This wrote it in its notation, z sub alpha notation. Okay, so long homework assignment. Let's continue on. We have problem 39 and 48 to manage here. Okay, let's move on to problem 38. Number of cookies in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed with a mean of 1,262 chips and a standard deviation of 118, according to a study by cadets. Looks like this was actually done. There's a source here, so that's interesting. And so what does this mean? Again, some key language in this problem. It's normally distributed, right? So we don't know what the data is, but they give us enough information in the mean and standard deviation so that we can then go ahead and draw a representation of that. I don't need to know what the data is. I just need to know what the mean and the standard deviation is. And so here's the distribution. If someone counted all the chocolate chip cookies in that bag and they looked at a whole bunch of bags, it doesn't tell us how many, but we know the distribution. We know the mean is 1262 and the standard deviation is 118. And so with that type of information, we can then go ahead and mark off and label off our standard normal our normal distribution, and then we can answer questions about that, knowing that there. What is the probability that randomly selected 18-ounce bags of Chip Ahoy contains 1,000 of 1,400 chocolate chips inclusive? And so in this case, all we're looking for, if we wanted to mark this off, is we have our normal curve, so somewhere within it, let's at least mark off a couple of these before. So add 100, so that's 1362. So this one here, this point here would be 1380. This point here will be 1498. And if we go backwards, so that's going to be 1162. So this would be 1144, and then go back another 118, so that would be 1044, 1026. And so on this first problem, for part A, the probability that a randomly selected 18-ounce bag has chips, there's my value, between 1,000 and 1,400. I can now answer, because remember, most of the bags have chips around 1,262, but some have down to 1,000 and some have down up to 1,400, 1,500. And so we're looking for the probability of a randomly selected bag having this amount of chips. And so that seems to be a value between here, 1,000, and 1,400 here. And so to answer that question, we would go to StatCrunch, change this here to 1,262, change this to 118, do it in between because I want it between 1,000 and 1,400. And what's kind of cool again is StatCrunch is going to draw that for us here. You can see that. And so that probability would be between, and those are the, that's if I want to look at it by standard deviation, or if we want to look at it by the values, and then you have it here, 0.866. So the probability is 0.866 for this one here. 0.866. Part B, what's the probability that a randomly selected 18-ounce bag contains fewer than 1,000? So we want X less than 1,000 chips. And so we would go back to StatCrunch. Oh, let's do a standard one. X is less than 1,000. Oh, the mean is still 1,262. I'm going to put 1,000 here because I want it to be less than 1,000. And so the probability would be that. And you'd want to draw this out. You get practice drawing this out so you can then draw the representation. So these, the ones in red here, are all the bags that have less than 1,000 chips. And that would be 0.013 or 1.3% of them. And so for this answer is 0.013. About 1.3% of those bags are going to have less than 1,000. And again, that would be a value over here. Part C, what proportion of contain more than 1,200? So again, kind of repetitious, greater than 1,200. So we would answer that one. Part D, what proportion contains fewer than 1125? So we would have that. Continuing on, E, what is the percentile? So that's a tougher problem. So let's do 1,200 and 1125 real quick. We want greater than 1,200. So we would have this one here. I just opened up Excel. Let me close that real quick. And so we want greater than 1,200. So we put 1,200 here. Greater than compute. So that's 70% for that one. So this is 0.70 for that one. Less than 1,125, so then we change that, put that to 1,125, put that as a less than, and now we get 0.123. 0.123. So what proportion? Approximately 12.3%. Here is 70%. Part E, what is the percentile rank of a 18-ounce bag? It contains 1,475 chips. What is the percentile rank? So in this case, slightly different question. We're going to do the same thing. And so you end up drawing that out. And then what we're doing is we know the middle, the mean is 1,262. And then somehow over here is 1,475. And so what we want to do is find the percentile, so that would be the area to the left of that. So what we're really trying to calculate is what proportion of people are below 1475. And so we get that answer, that would give us the percentile. And so let's go ahead, 1475 is what we need to put there. 1475 less than, so we get 96.4. And so for this problem here, this is 0.964. So this value here is around the 96th percentile. So that's where we would go, the 96th percentile. Or this here would be P96. So it's asked the same question, just asked it differently about percentile, which has to do with the area again. What was the percentile rank of that contains 1058? So on 1050. Again, we're going to go ahead and do that. We know the mean is 1262, and so somewhere over here is 1050. So we want to find that area again. This time to the left again, and so whatever that value is would then give us the percentile rank. 10, 0. It's going to get, because it's going to give us, it's a 1050 or 1075, 1050, compute, and so you get 0.036. And so the probability that x is less than 1050, 0.036, or the around the 4th percentile, since we round to the nearest percent, around the 4th percentile, that would be P4. Okay, let's finish this off. Number 48. 48. The reading speed of 6th grade students is approximately normal. So when 6th graders read and we measure their reading by how many words per minute, it looks like a normal distribution. The mean number of words per minute is 125. Standard deviation of the data is 24. Again, we don't have all the data. We can now just approximate it with a curve. What is the reading speed? Whose reading speed is at the 90th percentile. So what we're looking for is right here. This area is 0.10, or another way to think about it, the area on this side is 0.90. So the 90th percentile is going to be the area here. And so in order to answer that question, we then have to go back to StatCrunch. We need to pick off the mean and standard deviation, 125 and 24. Put 125 in there, 24 here, and then we clear that out, and I'm going to put 0.90 there because I want the 90th percentile. Compute. So 155.76. 155.76. And so in this case here, 175, again, and that value is coming from, was it one? That value is, 155.76. So it's 155.76 words. So about 156 words is the 90 percentile. School psychologist wants to determine the reading rates for unusual students, fast and slow. Determine the reading rates of the middle 95%. Remember, unusual is 5%, and so 5% is related to standard deviations. So what we're looking for are these values here, where these areas here are 0.025. 0.025, because that's 5%, and then the middle here, this would be the middle 95%. And so we need to find those values right there. And so we go ahead and use StatCrunch again. We have the data in there already. And so in this case here, I want the bottom to be 0.025. 0.025. And so that score is 77.96. That would be the low end. So the low end is 77.96. And if we want to find the upper end, We keep that 0.025. The only difference is I want this to be greater than. Compute 172.04. 172.04 is this value right here, 172.04. So these would be the values. So anyone on this side is unusual, and then anyone on this side is unusual also. So those are the scores. Anything below 77.96 or above 172.04 is considered unusual. That's it. Long homework assignment, but very important problems to understand.